Hi, how are you guys? How you doing? We're back to mathematical induction. Review 5. More practice, more understanding. More practice, more understanding. How you doing? How's everything? Now, we're gonna back to the geometric series. We're gonna back in more details about geometric series. We will discuss it, solve some problem, then improve it. Okay? Let's start. This is what I did yesterday for geometric series. Geometric series has something important, which is the ratio R. How to find R? By dividing. Let me choose green. Okay. This term by this, let's see, A1R over A1 give you R. And this give you R squared over R. And then you take any two consecutive terms and you divide them. If you get the same ratio, we call it ratio, right? Example, 5, 15, 45. If you divide 15 over 5, this will be the same as 45 over 15, which is 3. Good. Now, we call this guy the nth term. We call this guy the nth term. The nth term. I don't like the green. I feel it's too light. Okay, we call the nth term, which is A1 or n minus 1, if you want A1. Now I have here another form for the geometric sequence using the n term. We call this the sum notation. We call this the sum notation. We call this the sum notation. The sum notation. Now, the sum go from 1 to n. When this becomes infinity, we call this infinity. When this becomes infinity, we call this infinity series. Look here, this some examples from 1 to 5. I'm going to do it for you, this guy. 3, 2, okay. Somebody here telling me use different color. Somebody here telling me use a darker color. 3, 2. Now the first one is 1. 1 minus 1 plus. The second one 3, 2, 2 minus 1. Then 3, 2. Now we have 1, 2, then 3 minus 1, till you reach to the 5. Then, okay, 3, 2, 4 minus 1, 3, 2, 5 minus 1. 1 minus 1 is 0. 3 times 2 to the 0. 3 times 2, you see that? 3 times 2 square, 3 times 2 cube, and 3 times 2, the last one 5 to the 4th. Then you solve it, and then you get it done. 2 to the power 0 is 1, 6, 2 square is 4, 2 square is 4 times 3 is 12, 2 cube is 8 times 3 24, 2 to the 4 is 16 times 3 is 48. Then and you can add them up if you want to add them. Now notice something, my friend. 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2, which is the ratio here. Then you can get the ratio directly from here, which is R equal to. Now, And if you want to find the sum, all what you have to add, 3 plus 6, 9, right? Plus 12, 21, 45, plus this 48, right? The last one is 48. We just fix this one to make it 48. Okay, and but we're done. Let us deal with this one. You want from 1 to 4. From 1 to 4. From 1 to 4 equal to 1/5, 1 minus 1, 0, 2, 1/5, 2 minus 1 is 1, 2, 1/5, 3 minus 1 is 2. You following me? I'm plugging in from 1 to 4 because we have n minus 1. 1 minus 1 is 0. 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. 2, 1, 5, 3. Wow. Now you can finish it out. Anything to the zeroth power is 1. 2/5. And here 1/5 is 1. Let me just fix this 5. Okay, this is 1/25, 2/25. And here 1/1, 1/25. 2/125. You see that? 5 times 5 times 5, 125. Good. This is, just review. All what I advise you to back to the yesterday's video. I mean the video before this review 4. I'm just organizing your ideas for review 4 to prove the sum. I'm organizing it, I'm trying to make it as much as easy as I can. Okay. Now what we need to know more about geometry sequence, which is, look here, we face two cases. In this case, once the ratio is, look here how I wrote it here. I need you to be more professional. Look at R, absolute value of R greater than or equal to 1. Absolute value of R greater than. You can write it this form, R greater than 1 less than -1. And this I explained it yesterday, if you remember. In review 4, I explained it in review 4. I told you this is my number line. Actually, I don't have equal sign. You can be -1 and 1. When it's 1 and -1, when it's equal, I'm gonna delete this. I'm gonna delete this. I don't want 1 and -1 to be part of my answers. I'm gonna just write it as R less than 1. I don't need the equal sign. Okay, now we are going to the right and to the left. That means R is greater than 1. Example here. The sum of n terms is how many? 1 minus Rn. 1 minus, that's what I did, 1 minus R to the power n. Good? And 1 minus R. In this case here, A1, what's A1 equal? 3. Right? Now if I need the sum and R, what's R equal? You have to find R. How you find R? Divide 27 by 9 or 9 by 3. The same. 9/3 or 27/9. Both give you 3, right? Or 81 divided by 27. Now, let me use different color to find the sum of how many terms you need, guys? Okay. You need me to find the sum of how many terms? I'm gonna do 2. Sum of the 5 terms, sum of the 7 terms. 1, what's A1? What A1? A1 is 3. 1 minus, what are 3? How many terms we need? 5 terms over 1 minus 3, which is how much? 3 to the 5 is 243. 3 to the 5 is how much? 343. Because 3 times 3, 9, times 3, 27, times 3, 81, 243, right? And then 1 minus 243 divided by 1 minus 243 divided by negative 2, right? Why negative 2, guys? Why negative 2? Why negative 2? Because when negative 3 is negative 2, then my answer is 121. Just I need something from you. All what you need to do, 3, 9, 27, 81. What's the number after this? Here 243. This 121. This 121. If you need to know what this answer, look here, 3 times 3, 9, times 243. Right? 1, 2, 3, 4, and 5. The first 5 terms, I forgot to multiply by 3, right? I have to multiply by 3. This number is, okay, you can do it, okay. Okay. 321 times 3, 363. If you want to try it, you add 3 plus 9, 12, plus 27, plus 81, plus 243. That gives you 363. Try it, but use this one. 3, it's the 7th term. 1 minus 3 to the 7 over 1 minus 3 equal. You have to use calculator for this. 3 to the 7. 3 to the power 7. 1 3 to the power 7. Okay, 1 3 to the power 7. 1 3 to the power 7. 1 minus 3 to the power 7. 1 minus time 3. 3279. Okay, you can try. Add the 7th term. Keep going. This multiply by 3. This multiply by 3. This another example. 1 plus. What's my R? First R. The ratio. The ratio is that between 1/5. R equal 1 over 5 over 1, which is 1/5. You can find it also, divide this by this or this by that, divide. And A1 equal 1. Now the good thing about this type of geometric sequences, the good thing about this is the sum is the same. You don't have to find, as the first sum of the look here, the sum of the first 7 terms is the same as the sum of 8 terms. It's the same as the, it's not exactly, I'm going to put an equal sign here, it's approximately, because that we will find S of n, you know what I mean, for all of it. Then the sum of this geometric sequence is almost the same for all the values. And I cannot tell you, it's a sum of 1 is 1. I don't want to get to that point from one of the students and tell me what sum of 1, the first, because sum of the first term, we are not asking about only the first term, we need the sum of the series. And if you tell me sum of the 3 is 3, now we start to talk. It's 3, you add this and this and this. It's 4, you add this one. S1, it's only 1, I don't need to know. Then let me find Sn. Let me see what's Sn. You see? Ismail, you see that? Sn, the sum of the n geometric sequence. Is you apply the formula A1, 1 over 1 minus R is how much? 1, 5, 1 over 4, 5, which is 1 times 5, we use calculator, 5 over 4, which is 1.25. It's a common sense. Because look at 120, okay, 125. Then if you take all the terms from 1 to infinity, from the first to infinity, it's about 125. Okay, more practice. Here what we have, from 1 to the 4, 2, negative 3, 1 minus 1 is 0. Only 4 terms. 2, negative 3, 1 minus 1, we did 2 minus 1 is 1, plus 2, negative 3, 2, plus 2, negative 3, 3. It's 4 terms. From 1 I went to the, good. And this solve it, this 2, this is negative 6, this is negative 3 squared 9, 18, minus negative 3 cubed, negative 27, times 2, negative 54. Now notice here, the ratio is negative. R is what? R is equal negative 3, which is clearly here. And A1, what A1 is 2. And then the sum of only 4th term, A1, 1 minus R to the n over 1 minus R, which is 1 minus R, which is negative 3 to the 4, 1 minus negative 3, R is negative 3, 1 minus 81, negative 3 to the 4 over 4, all time A1, and A1 is how much? A1 how much? 2. A1 is 2. And then 2 times negative 80 over 4. If you multiply in the calculator, there's going to be negative 40. Right? Let me try it. You can add it. Look here, 2 minus 6, minus 18 minus 60. Wow, that's clearly right. If you add these two, negative 60, and this 20, negative 40. Another example here, this guy, negative 2, 1/3 to the 0, plus negative 2, 1/3 to the 1, negative 2, 1/3 to 2, negative 2, 1/3 to the 3, negative 2, plus because I have plus, right? Negative 2, 1/3 to the 4, equal negative 2, because this guy is 1, and this is plus negative 2/3, negative 2, 9, 1/3, right? And this is negative 2 over 27, because 3 cubed, 3 times 3 times 3 is what? Minus 2 over 81. And to find the sum here, it's easy way, sum. And now since the ratio is R here, is 1/3, right? R is 1/3. R is 1/3. And A1 equal negative 2. Then find, guys, the sum. What the sum, in this case, what the sum? Back to the note here. The sum in this case is what? This is your sum. A1 over 1 minus R. Sum for any Sn A1 is negative 2, 1 minus 1/3. Negative 2 over what? 2/3, which is negative 3. Which is negative 3. I want to write it one more time down, this guy, for this. Here, Sn 2, negative 2, because we have negative 2. 1 minus r is 1/3 r, and A1 negative 2 over 2/3, which is negative 2 times 3 over 2, which is negative 3. If you want to make sure from my answer, you can add your guys here. Negative 2, this here, negative, you see that? Negative 2/3, negative 2, 9, negative 2 over 27, negative 2 over 21, add these terms. And you will get the answer. Thank you guys, thanks a lot for having me today. Please review, keep reviewing, review all what we have here. Review the notes, review the notes. It's called review 1, 2, 3, 4. As much you review, as much you understand. As much you review, as much you understand. Thank you, and have a nice day.